10 seconds early. We are 10 seconds early, which I really like,
Jingle. Sorry, I thought we were going to sing a jingle before. I thought you said we were going to do a jingle.
You want to do a jingle? You can do
We
it.
all agreed we would do a jingle.
Not sure. Okay.
We all agreed, and then we went live 10 seconds early.
Yeah. Because I think 10 seconds, like being 10 seconds early is even better than being on time.
That's the German in you speaking.
Yes, exactly.
Maybe you can elicit a jingle in flight of this session. But we'll see about that.
We'll see about
that. Not a great. Sorry, I'm gonna log off. You guys continue.
Wait, you guys do the intro. I'm gonna do a surprise. I'll be off screen, but you keep talking.
Oh my God, I'm not sure if I'm worried now or if I don't know. I don't know what's happening here.
Yeah, I think I know what's gonna happen.
Ah!
Okay.
Ah!
If someone is wondering, this is how we normally work in the office. Brett is coming to our rooms and is screening into our computer, and then afterwards our code works again. So this is how we operate as a team.
This is called pair programming.
Did you talk about what we're going to talk about?
We did not talk about. We were awaiting the surprise.
Okay.
We talk about our work ethics, how you come to everyone's room screaming into the screen, and then the code works again. So this is how we work as a team. No, I was confused by what you're going to do. So
I know I'm the wild card.
You're the wild card, but yeah, I mean today we talk about architecture choices in MCP, and the first one we have on the list is state versus stateless, like how you want to build your MCP server and how you run it, basically. And then the second one is a very hard word to pronounce. It's called elicitation.
Elicitation.
I did an okay job on that.
Yeah, of course.
So maybe we can start with state and with a serverless and the stateful approach.
It's the less fun topic, so we should start with it. And I'll try not to make it too boring, because I'm still, honestly, I have some open questions in my head about it. And I'm not sure if I totally understand the distinction, because it's not really spelled out in the spec. I guess, okay, so the way that I came across this is twofold. One, there is a library called fastmcp for Python. I'm just going to share my screen. Might be easier. You're going to see everyone. So fastmcp Python, and they have an actual, okay, there we go. They have an actual switch when you, do they? Will I find it? When you instantiate a server, you can say stateless true or not. And let's see, stateful. Am I in the wrong place? I might be in the wrong repo. Okay, at any rate, you'll have to trust me that there is somewhere a Python library that has a switch for making your MCP server stateful or not. And I think in that case, what that means is kind of whether or not you support the, in the streamable HTTP context, whether or not you support a GET route that allows you to accept a stream of events with no termination until you say so of what's happening on the MCP server. So it can be any notifications, responses, etc. So you're just getting information as it comes from the server. And in order to do that, you need to have a session ID associated with your MCP session connection. And that allows you to receive the correct events coming down the wire. And so that makes it stateful in the sense that multiple requests are correlated. Yeah, the other part that I understand about this discussion is whether to make MCP servers fully embrace statefulness or not was a contentious topic at the last meeting of the committee, a little bit because statefulness inherently does not play well with the world of serverless. And there's a lot of infrastructure providers who are at the table for discussions on MCP servers, and I don't think they like it, / a lot of companies who are already on serverless wouldn't necessarily like it if this next big technology or protocol was inherently stateful, because that means their infrastructure they've built up all this tooling around just out of the box wouldn't work with it. I will say, part of me wonders whether you could still do so. Like a little bit of a rule of thumb is you don't get things like sampling or elicitations with a stateless server, but I'm not sure if that's true. I think there's like ways around that, and that's the thing. We're not going to discuss this today because I have no idea. But that's something that I've been thinking about in the back of my head for the past week. This stateless versus stateful distinction came into play as we added sessions to mcp-lite. And so now by default, we do not include any form of session store when you create an MCP server with mcp-lite. You have to like opt into that. There's a little bit of like some of the logic around that is specifically configuring a store means that you're aware of the fact that you might be using something that's not fit for production. So in that way, like adding an in-memory store to Cloudflare Worker will work locally and will not work in the cloud because your worker, multiple requests to different workers are not really correlated in any inherent way. And there's no way for them to really communicate with each other. I mean, could be a way, a very hacky way, and that's the thing that's in the back of my head. So this is a little bit, I know this is a terribly good distinction, but it's stateful versus stateless. I have basically come to think of it as like, do you support that stream of events on the get route or not? No. Yeah, and sessions. Do you support sessions?
So would you say the default for now has been people building stateless?
Stateful.
Stateful. Yeah. They have built stateful. Okay.
In fact, like I think the TypeScript libraries, except for mcp-lite, assume statefulness, and you have to opt out. Yeah.
Yeah. Okay. I think they added statelessness as they added the streamable HTTP support. Yes. For example, with the now deprecated or to be deprecated SSE transport, where you had 2 endpoints, you wouldn't be able to have an MCP server that was stateless because you inherently needed to have information that needed to live across requests, which means it needs to persist some kind of state that can be shared between these 2 requests. And that means that then in a serverless world, you're out of luck because anything that once the request ends, the assumption is sort of burn everything. There's nothing that persists after.
Yeah, and this is also why the original templates from Cloudflare for MCP servers all used durable objects, because durable objects are stateful and workers are not in that way.
Yeah.
I see Samir here giving a comment that he's new here and he needs a brief background what we are talking about.
What have we been talking about?
What are we doing here? So this is called Honc out, and it's all around the Honc stack, which consists of Hono.js as a web framework. There's ORM, which is Drizzle. Then there is Name Your Favorite Database and a Cloudflare Worker. But this special edition is focusing on MCP stuff, because you can also build MCP servers using the Honc stack or using Hono with the library mcp-lite. And we've been digging a lot into MCP land nowadays. So we discuss a lot of those topics because we are interested how the space will shape and what is new in the MCP land. So I hope that explains it a little bit. Do you like to add, Lau or Brad?
Nope, that's basically it. So, I mean, I guess in this case, when we're talking about Honc, and we're talking about Honc on Cloudflare, that would imply a stateless MCP server until you bring in something like a durable object. If you're running Honc on like a node server, You could go stateful by default. You just need some logic on that server for handling that state. And when you scale it horizontally, so if you have multiple copies of that server running, then that statefulness becomes much more complex to manage.
Can you like give me a little bit of a what is a trade-off if I go for stateless, for example? If I do the stateless, do I have a trade-off I have to think about?
Yeah, I mean it's effectively what capabilities your server exposes. But like I said, like an asterisk here being there might be ways around that, but they're not like you'd be misusing a serverless architecture if you went that route. So stateless still supports tool calls, prompts, resources. There's just your ability to like notify a client. Again, this is also an asterisk because you can still kind of send a stream back to the client. But your ability to do, I would say, like out of loop things. So just like spontaneously tell the client, even when it's not making a request, just spontaneously be like, hey, the list of tools changed. There's a new tool available. There's a new resource available. Like those types of notifications couldn't happen outside of the request and response of your client. And so that's what you lose when you do a stateless server, as well as possibly, but maybe not, sampling and elicitations, depending on how you make things work.
Yeah, I don't think you can get elicitations and sampling working. We can get into how elicitations work by showing that, but like thinking about this loud, I don't think without sessions you can get them working. And if you have sessions, you have some kind of state.
Yeah. I think we'll see another week. I think there's a way of hacking it, but it's not what the protocol intends. But yeah, that would be and also like I think you would just pay through your teeth for serverless bills, and you'd have to manage like the max connection length that you're allowed on your serverless provider and stuff like that. So it would be like you shouldn't do it, but maybe you could.
Yeah, maybe you could. Shall we get into elicitations?
Yes.
Sure.
But we should define them because
yeah, let's I shared my code screen and I realized I wanted to share the answer is always read the spec, but it might not be obvious.
We should make that shirt.
Yeah, we should. Okay, I'll quickly show the spec and then I'll get into a demo and I'll show you how that looks like in the code. And that should hopefully both explain what elicitations work and maybe sort of tie it a little bit together with sessions as well. So elicitations at a basic shape in the most simplest way is for a way for a server to request more information from the client in flight. So basically, let's say you make a tool call, and then as that tool call is being executed, you have some logic that says like, oh, well, we're going to need some extra information. Or that can be as simple as confirming the action, or it can be something like, confirming an action with like a comment or adding some extra information. Specifically, they're not supposed to be used for any sensitive information. But they're meant to be used by the human. There's another version of this where the client requests the model, but we can get into that later. I don't know if we talked about sampling earlier, but that's sort of the same shape of this feature. So it's sort of, I mean, this is the spec section, and now as I sort of realizing it, as I'm showing it, I realize it. Let me just pull up the demo, and maybe that will.
Yeah. So I don't know what you're going to demo, but while you pull it up, I'll say the way that I explained it earlier to Nella, which is like, imagine you have a tool call of order T-shirt, and then the model comes back and has a very like a structured form that says like select size, so that could be small, medium, large, and maybe like select color. And in that case, if they're very simple inputs, that's part of the spec, is you can't really do complicated nested forms yet. But it's a way to just gather structured, non-sensitive information from the human that is using the thing, and then use that to process the tool call.
Yeah. That would go back to the client or to the host side where the user then has to give the parameters, right? So you would reply with M and red or something like that.
Yeah, so it's the responsibility of the host to implement the UI around this.
Okay.
Yeah. So this is some, for example, it's similar in shape. You know, you could ask it like you could prompt the model to ask you one by one, or you could program this in your tool call, for example, to send requests in flight to request for more information. It's very dependent on client support. Most clients don't currently implement it except for VS Code's GitHub Copilot chat, MCP Inspector, of course, just for sort of debugging purposes, and maybe a couple of others. So I just pulled up this example on the VS Code example, and we'll see if that can work. So what we have here is a tool defined in the mcp-lite that is just collect feedback. And the input for that is only a topic. So let's try this. Let's collect feedback on JS frameworks. Let's see if this works. So I kick off this request, and it's not calling that tool. Let's see. Let me quickly verify this is running. I'm going to restart the server just in case. Use the collect feedback tool. Yeah, so now it's running the collect feedback tool. I allow it. And now I get this form that I can respond to. So the first thing in here is you see there's rating. So the input is a number, rate your experience 1 to 5. So I don't know, let's add 4. We then have an enumerated variable here. That's the other part in this feedback schema. So this is now asking, it's like, okay, I don't know, this is general feedback. And now we can add a description. This is demo feedback on elicitations. And email, I'm going to choose none. Would you like us to follow up? False. And see, so now this has sent this information alongside. And I think it's still running.
Follow up. Can you zoom in, or perhaps?
Let's see.
Oh yeah, that's better.
Okay. This is the first time I'm running this tool because I whipped up the demo right before it. So I'm kind of curious what happens.
Can you have your server? Do you have your server logs somewhere, or are they outside of our? Can we not see them?
They are here, but request timed out. So I think this is what happened essentially.
Okay, yeah, I think this is the on idle timeout. So while I was waiting for
the input, it sort of timed out. I can run it again,
and then fill it in really fast.
Faster.
We're just going to do the same thing. Yeah, discovered. Use it again for React.
All right. Timer is going to start.
Okay, so we get the input form. I like React, so it's 5 out of 5. General feedback, good framework. No email, no follow-up. Okay.
Yeah, I think there's something wrong with the async stream that it's trying to read from. Oh wait,
yeah,
no,
it's still timed out.
Okay.
You were so quick this time, so I was.
I was hoping as well. So we're not going to get the output from this, but we can kind of quickly walk through of what's happened. Is we initiated the tool call. First, there was a quick check if the client supports elicitation. It does, so we were able to continue. Then there was the elicit call, and this was this. You can see the little shape of the form. You can add whatever content you want in there, and then it has three possible. The elicitation action has three possible outcomes, which is accept, decline, or cancel. And so when we submit our answers, we say accept, along with some extra information. So here in this case, result action accept, we can do something with that information. So in this case, it would convert the rating into the appropriate emoji, and then it would sort of hopefully respond with this feedback if I was able to complete this in under 10 seconds. There's a simpler version. I'm going to stop this tool request. There's a simpler version. Let's see if that one works. That's just execute task.
Do you also have the inspector too, maybe this one, if it's possible?
I can take the inspector. Let's see.
Maybe we need to reduce the questions you have to answer, like only one input.
Yeah. One input on the. Okay, so this is the inspector. I'm going to reconnect. And then, let's say we collect feedback. We run the tool. And now we're in elicitations. So we can do 5. We can do general feedback. Good framework. No email follow-up.
Yeah, you may have gotten a timeout again.
I think I've gotten the timeout. Let me check.
Well, we should, yeah.
Might need to investigate this a little more. This is still an open PR. What is not even in the framework, and the elicitation spec is obviously evolving, but it gives you a little bit of a sense of sort of how this works and the features that you can get while working with it. The most simplest form, of course, is this. So let's say execute task is another one. Requires backup, and so it sort of
Yes.
Yeah.
I managed to finish within 10 seconds. So I got the full flow, but we got a tool call that was execute task. We got doesn't get registered as notification, but is effectively a similar shape thing, just sort of a request that is sent from the server into the client using that same tool call, the same post request response stream in the tool call. And then the client sort of pauses there and tells you to fill in the information that we saw in the elicitations. I'm going to reset the bun 10-second timeout after this for the next demo, so I don't have to rush through this. But this is sort of to give you an idea on what elicitations are.
Okay, nice. And well, if I sum it up correctly, this now needs to run with state because of like getting back and coming, like, the elicitation needs a state, right? So that's why you run it on bun. And it would probably not work if you run it on a serverless environment, or would it?
So that comes down to the API that we went with. We initially sort of the default is in memory. So maybe what you need to do to get elicitations working is, so a client makes a tool call request into the server, and then the server starts executing it and hits the elicit call, like in our handler that we saw, the context.elicit. At that point, it sends a request back to the client for this extra information with the schema provided. And it awaits, like the only way in the HTTP land it can await a response is on a separate post request. So we're already in land where we need to cross-reference two different requests or information coming in on two different HTTP requests. While one is in flight and holding, the other one provides the information that is needed to resolve the first one. So in the most simplest terms in a stateful world, you would keep all of that in memory, and it's all running in the same process. So you just sort of, you have effectively a map of promises, and you store, once the elicitation request is created, you store that promise in the map, and you retrieve that promise on the next request that posts the response. It's very confusing to use the HTTP request response terminology with the MCP request response, because we're flipping it around in the MCP land, in the elicitations land. So feel free to let me know if you're not following. The main thing you need to do in serverless is like all of these two separate requests are run on two separate processes. So there's no way to share memory. Huh?
I said maybe.
Maybe not. You have to assume that they're not.
Yeah.
And so in what we did, let's see if I can pull this up. Instead of just assuming that everything is going to run in memory map, which is sort of when I did the initial pass of the implementation of this, is like, oh yeah, of course, in memory map. And then we discussed with Brett, and I was like, oh, but what if you're running in serverless?
Yeah, and it worked locally with a serverless-like setup, because locally, locally the serverless function still had memory that was shared across multiple requests.
Oh yeah, that's what you mentioned at the beginning as well, right? So now it makes sense.
Yeah.
Like after seeing code, it makes more sense for me.
Yeah. So I think the current way we're thinking of it is you will still need to hold that request, which in serverless environments where you're maybe paying for wall time might be expensive. Yeah. But in, for example, Cloudflare, you're not. So that's fine. That will still have to hold, but you will need some kind of stateful layer, like a key value store or a durable object or a database or anything, to share information between two different processes that tell the request that is holding that it can now release and continue with the information. And so our approach to that was, we've sort of taken into the adapter model, so beginning with the standard schema adapters, with the session adapters that Brett talked about earlier. Similarly here, this is a client request adapter. We might need a better name. PR is open. Effectively, it's a way to define how to do one of three, well, all three things, which is what happens when you create a pending request, means you freeze that execution. How should that be resolved, and what should happen if you reject, if that request rejects? So in something, I don't know if I don't have it here. I had somewhere a sample, I think in the README of that PR. I've added there's a sample Cloudflare KV adapter that you could implement with timeouts and everything, where you are sort of sharing that information across the key value store, and you're still able to use something like elicitations in an environment that is inherently very stateful.
Cool. I mean, I'm looking forward if the PR gets merged. So we have more on that then.
There's going to be at least several days of back and forth on how to name the adapter.
Maybe we should ask people if they have an idea how we should name the adapter.
I have a tendency to name things I never wrote Objective-C or Cocoa or anything, but I really appreciated how long they made class names and variable names. And that is definitely my bias. So I'm thinking something like request response correlation adapter.
Oh.
No abbreviations, none of this rec res core. It's all fully spelt out.
Yeah, and then if you can also include some words that are very hard to pronounce, you make everyone's life very happy, I think. So
Squirrel.
Request response correlation adapter for elicitations.
For elicitations, and then just add on squirrel, because I feel like for non-native English speakers, squirrel is just a nightmare word.
Yeah,
that could work. No, but I think we talked like for half an hour about interesting things in MCP.
I saw Samir wanted to see us increase the bun timeout and make it work. My challenge to you, there are several different ways to do it. The example is on the PR. If we want to give it a whirl, we'll probably try and update it ourselves. But yeah, you can either run like bun timeout on all requests and then set it to 0, so there's no timeout. And then I forgot how to actually like permanently set the idle request limit higher. If that's I don't think that's an environment variable. Maybe it was. I don't know. But it's an exercise left to the reader.
Left to the reader until we can show it or until we've done something on it, right?
Until we do it ourselves. Which will be soon.
Soon. Maybe next week.
Maybe tomorrow.
Maybe tomorrow. But maybe we can show it next week then.
So, yeah, maybe we show it next week. Yeah. Hopefully next week I can show something around we've got something cooking with observability middleware for mcp-lite servers. I'm not exactly sure what shape it takes yet, but I guess this is my teaser. We've talked long enough. There'll be something to do with getting data about tool calls out of an mcp-lite server so that you can debug and inspect what's going on.
I'm looking forward to that. I'm curious to see that.
Yeah.
Cool. With that, I think we can end.
Cool.